Okay, these are your notes, 4.2, angle relationships in triangles. And before we get into the meat of it, we have a new vocab word here. It's called an auxiliary line. So let me define that for you. So an auxiliary line is a line that's added to a figure to aid a proof. So it's something we're going to add to the original picture that kind of helps us figure some things out. So look to your right here. We have this triangle XYZ. So we're going to say given triangle XYZ, what we want to prove is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Well, you might be thinking to yourself, well, I've known that since 5th grade, that the three angles of a triangle add up to 180. But we're going to prove it today, and we're going to use the help of an auxiliary line. So we're going to put our statements, and we're going to put our reason here. And so the first thing I'm going to do is, looking at side XZ on my triangle right here, I'm going to draw a line that's parallel to XZ up here at the top of the triangle, going right there through the vertex at angle 2. And that line is going to be parallel to XC. And so number 1, we're going to put add auxiliary line. Well, let me see here. Let me do that differently. That's going to be our reason over here. And I decided to name my line L. So so we're going to put add line L, and we're going to write adding auxiliary line. So, and I think I'll add on here, add line L parallel to line XZ. Now, because I have that line, I'm just going to go ahead and label. We have two new angles that have formed there, and I'm just going to label them angle 4 and angle 5. We're not really adding them. I'm just labeling them. We added them by virtue of the line. So now let's go to the second part of our proof. What do you notice about these three angles that we have angle 4, angle 5, and angle 2? That if we were to add up the measurements of those angles, they would add up to what? What would they add up to? Well, they end up forming a straight line, so they add up to 180. So let's add that to our proof. So we're going to say the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. And we know that by the angle addition postulate. You add up angle parts and they make a whole. So angle addition postulate. Now let's go to number 3. Here's what adding that line helped us do. When we added that auxiliary line, now we can see XY here is a transversal. And so when you have a transversal like that, we can say that angle 4 is congruent to angle 1. How do I know that? Because if these two lines are parallel and they're cut by a transversal, then the alternate interior angles are congruent. So let's do angle 4 is congruent to angle 1. And we're going to say if two lines are parallel, alternate interior angles are congruent, right? So that should help you know what to do for the next one. How about we look at this auxiliary line over here. It's not an auxiliary line, but it's a transversal. Since we added the auxiliary line, you can see YZ is a transversal, and so we can say angle 5 is congruent to angle 3. So let's write that. Angle 5 is congruent to angle 3. And same thing. If two lines are parallel, alternate interior angles are congruent. I'm sorry I'm not writing that out, but just in the interest of time. Okay, now we can say, since we know those angles are congruent, we can add into our proof that the measure of angle 4 is equal to the measure of angle 1. What's that? Definition of congruent angles. And then we can say the same thing about the measure of angle 5 is equal to the measure of angle 3. We know that because we've already proved they're congruent, so we can say definition of congruent angles. Okay, now we can get to our proof statement. At this point, I can prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. And I want you to see how I did that. We can see here that 4 is congruent to 1, and therefore the measure of 4 is equal to the measure of 1. So I took this 4 out and I substituted it with 1. And then angle 5, the measure of angle 5 is equal to the measure of angle 3, so I took this 5 out and substituted it here. So we use the substitution property of equality. And there we go. We've just proved that the 3 measures of the angles of a triangle add up to 180 degrees. Bam! 1, 2, and 3 equal 180. So we did that with the help of an auxiliary line. Now I will tell you, we don't use auxiliary lines a lot, and generally speaking, if I want you to use one, we'll usually give you a hint of some sort. Say, adding an auxiliary line might be a good idea. So there you go. Let's go on to some other angle relationships. We're going to go to example 2. And actually, I think you could do number 2 without my help. Why don't you read that problem and answer the question real quick. Hit pause and do it yourself. Okay, so I hope you have on your paper that the missing angle is 59 degrees. And you can see my work here. I made a drawing. The 2 angles that we had, I put in 76 and 45, added them up, subtracted from 180, and we got 59 degrees. Okay, example 3. It says find the measure of n and the measure of each angle. So again, I think this is a problem you should be able to do without me, knowing that the 3 angles of a triangle add up to 180. So try it again without my help and see how you do. So please hit pause and do this work yourself. Okay, so I just took the 3 angles, 7n minus 8, 6n plus 4, 2n plus 4, added them together to equal 180. And you'll notice that the minus 8 plus 4 cancel each other out. So we had 15n equals 180, n equals 12. And then I plugged that in to get the measurements of the angles. So you'll notice that this angle R is 76, and this angle T is 76. So this is congruent to this, which means that this side is congruent to that side, and so therefore, I know I didn't ask you in this question, but this is an isosceles triangle, and not only isosceles, but we see that all 3 angles are acute, so it's an isosceles acute triangle. So if you were asked to describe the triangle, that's what it would be. When these angles are the same, these sides are congruent as well. Okay, let's move on to example 4. Okay, on example 4, it says the measures of the angles in a triangle are in the ratio of 3 to 4 to 5. Find the measure of each angle. Okay, so if we have a triangle, I'm just going to draw a triangle. If we have a triangle and it has a ratio of 3 to 4 to 5, what we don't really know is the exact amount of the measurements, but we know they have a constant ratio. So what we're trying to find out is the scale factor that is used for each one of these. So we're going to put in x, which with the 3, the 4, the 5, so that whatever x ends up being, we can multiply that times the 3, the 4, the 5, and figure out the measurements of the angles, and they will all stay in that same ratio. So to set up this problem, we're going to say 3x plus 4x plus 5x equals what? The 3 angles of a triangle add up to 180. So we add those together and we get 12x equals 180. Divide by 12 and x equals 15. Now once I know that x equals 15, we can plug that in because we're going to maintain our 3 to 4 to 5 ratio. So 3 times 15 is 45 degrees. 4 times 15 is 60 degrees. And then 5 times 15 is 75 degrees. And if you have any doubts about whether or not you did that correctly, add these up and let's make sure they add up to 180, and they do. So there you go. This would be, well, okay, that's it. 45, 60, 75. Okay, now let's take a look at a new vocabulary word called corollary. So here's the definition of corollary. A corollary is a theorem that leads easily to another theorem. And we're going to show you an example of a corollary here on example 5. So it says the measure of one acute angle of a right triangle is 23 degrees. What is the measure of the other acute angle? So let's first of all draw our right triangle. So I'm going to draw a right triangle, put my little right angle there, and let's say that we label these angles 1 and 2. And so if one of those two angles is 23 degrees, we know that 23 degrees plus 90 degrees plus the one that's missing. Let's say it was angle 2 that was 23, and angle 1 we don't know, we'll call it x. So the missing angle, those all need to add up to what? To 180, because it's a triangle, right? So we have 113 degrees plus x equals 180. And now we subtract 113 from 180, and we get 67 degrees. Now that was one way to figure that out, but I want to suggest to you that there was another way that we could have figured that out, and that would be that if we know this is a 90-degree angle, then we know that 23 plus x, the two remaining angles, have to equal 90 degrees, right? So we're going to subtract 23, and we get x equals 67. And this leads us to a corollary as follows. It's a corollary to what we proved above. The two acute angles of a right triangle I'm going to use a symbol for triangle, are, and we're going to put a word right in here. What word are we going to put in for two angles that add up to 90 degrees? We're going to say they are complementary. Good? So there's a corollary. The two acute angles of a right triangle are complementary. Okay, let's turn the page. Now, thinking about what we just showed on that last example, that the two acute angles of a right triangle are complementary, that's going to help us do example 6 here. So it says the measure of one acute angle of a right triangle is 90 minus z. What is the measure of the other acute angle? So I'm going to go ahead and draw a right triangle. And we know that the measure of one of these is 90 minus z. Now, what I'm going to do is do another example, and we're going to actually put some values because we don't know what z is in this problem. Didn't tell us anything about z, did it? So what I'm going to do over here is make another right triangle, and we're just going to do some samples and see what happens. Let's say that the measurement of this angle right here is 20. And we know from our previous example that the two acute angles of a right triangle are complementary. So if I wanted to find this angle here, I'm going to put, well, let's call it Z, since we're using Z's. Let's call it Z. If I want to figure out what Z is, I would have to take 90 minus 20, and I would get 70, right? Because we know they add up to 90, and so we took that and subtracted it. Now, what if that angle was 30 degrees? Well, we would do 90 minus 30, and we would get 60, right? And then we try it again, and we try 40, and we do 90 minus 40 equals 50 degrees. Now, let's see what we notice. These right here are all 90 minus the angle that was given. And you know what, that just, I kind of think that I should have said something differently than I did at the first. Instead of calling this one Z, we know this one is 90 minus Z, right, from our other deal. We are making up some values for Z right here. That's what we're doing. We're making up values for Z. So what we had to do in order to figure out the remaining angle was to take 90 minus Z, whatever Z was, and we got the answer. So looking, this 70 was 90 minus Z when this one was 20. This one was 90 minus Z when it was 30, and this one's 90 minus Z when it was 40. So let's write an equation. We can say 90, we took 90 degrees and we subtracted 90 minus Z, and so that would be 90 negative 90 plus Z, and these cancel out, so we're left with Z. So we know that the measurement of this angle really is Z. Now I did it using some examples, some real numbers, but I just wanted you to see that if this one's 90 minus Z, then this one has to be Z if it's a right triangle, because that's how we figure out the two other angles. We take 90 and we subtract the one that we know. So that's just to prove that up. I hope I didn't confuse you on that. Okay, so now let's go to the next activity. Okay, so this says exterior angle activity. So the first thing I want to do is define what an exterior angle is. So the definition of an exterior angle is, and let's write it, an external, or exterior, not external, exterior angle is the angle formed by one side of a triangle and an extension of the adjacent side. Now that's a lot of words, but it might make a little more sense if we look at the picture. Okay, here's a triangle, and here's a side of the triangle. It says, so it's an exterior angle is the angle formed by one side of a triangle. So here's my one side, and then an extension of the adjacent side. So an adjacent side is one that's right next door. An adjacent side is the one that actually forms this angle right here, and then we're going to extend it out here, and we create this angle. That's the exterior angle. So it's one side of a triangle, the adjacent side, and then we extend that adjacent side, and it's the angle formed by those two sides. Okay, so let's move on and do the little activity. So what I want you to do is to number these 1, 2, and 3, and we'll call the exterior angle number 4. So what we want to do is try and make some kind of prediction about what the value of angle 4 is. So what do we know for certain? When we look at angle 4 and angle 1, that's a linear pair. So I know that the measure of angle 1 plus the measure of angle 4 equals 180. Now let's see what else we know in this picture. I'm going to erase that linear angle right there. Now, inside the triangle, we have angles 1, 2, and 3. What do I know about those angles? We know they add up to 180, so I'm going to write that down. We say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Now, since both of these equal 180, let's use the substitution property, and I'm going to take this and substitute it for the 180 up there because it equals 180. So we're going to make a new problem here that says the measure of angle 1 plus the measure of angle 4 is equal to the measure of angle 1 plus angle 2 plus angle 3. I'm squeezing it in there. Now let's see here. We're trying to make a prediction about angle 4. So if I want to solve for the measure of angle 4, I'm going to have to subtract the measure of angle 1. So I subtract the measure of angle 1, subtraction property of equality, and what do I have left over? These ones cancel out. So I'm left with the measure of angle 4 is equal to the measure of angle 2 plus the measure of angle 3. Bam! So this number 4 angle is going to be the same measurement as these two added together. And so now we can write a little corollary that says, let me use a different color. The exterior angle of a triangle, now remember, exterior is one that's out here, it's been extended from the side. The exterior angle of a triangle is equal to the sum of the two, now this is key word, the two non-adjacent interior angles. The non-adjacent interior angles. So let's make sure you understand what we're saying. Here's the exterior angle here, angle 4. The angle that's adjacent to it is angle 1. It's on the inside, on the interior. 4 is on the exterior. So the two non-adjacent interior angles are these ones that are over here across from it. They're inside, interior, but they're not adjacent to angle 4. So these two are going to be the same measurement as angle 4 when you add them up. Okay? Good? Let's keep moving. So given that information, could you try to then do example 7 and 8 without my help? I want you to hit pause, and I want you to give it a shot on what those measurements are. Okay? And then come back and check your work. Okay, here's the first one. So we know that this is a linear pair right here. I want to point out some things that we know. I'm going to erase what we've got right there. We know this is a linear pair. So if it's a linear pair, we know that angle 1 plus 120 are going to equal 180. So subtract, that's what I did right here. I subtracted 120 from 180, and so we know that angle 1 is 60 degrees. Now the second thing we know from this picture is because this is an isosceles triangle, it had these markings. That means that this angle, the angles that are across from it, angle 1 and angle 3 are going to be the same. So that's what I did in the next part. Since angle 1 and angle 3 are the same, and we know that angle 1 was 60 degrees, that means angle 3 is 60 degrees. And now at this point, there's several things you could do. We know that 120 adds up to these together, so I did that. I subtracted 60. 120 is equal to 2 and 3, and so I substituted 60 for 3 and found out that angle 2 was 60 degrees. Or the other thing you could do is, once you know this one's 60 and this one's 60, they all three add up to 180, and so 180 minus 120 again is 60. So not only is it an isosceles triangle, it's actually what kind of a triangle? It's equilateral because all three angles ended up being 60 degrees. Now let's do example 8. Well, you do it yourself. Hit pause and keep trying. Okay, so on this problem, since we know that the exterior angle right here, this is the exterior, is equal to the two non-adjacent interior angles. So I set up a problem. 9x plus 2 is equal to 5x minus 1 plus 23, and then solved it out. You can see all my work there. We get down to x equals 5. Then I took the 5 and plugged it in. So 9 times 5 right here, 9 times 5 plus 2 is 47. 5 times 5 minus 1 is 24. And then the other angle that was given to us originally was 23. So let's add those up. They're 47 degrees, and so it works. The exterior angle and these two end up being the same. Okay? Let's move on. Oh, well, let me ask you one other question. If I wanted to know what the measurement of angle PRQ is, this angle right here, what would I do to find the measurement of that angle? And that measurement of that angle is going to be 180, because this is a linear pair, minus 47, because we figured that one out, and so that one's going to be 133 degrees. Okay, so now I'm going to help you out on this next problem a little bit. It says use the picture and the third angles to write and prove a statement, and then to write a proof statement, and then write a two-column proof. So first of all, let's look at what we're given. Let's look at the pictures. We know from these markings right here that angle A is congruent to angle D. And we know because of these markings right here that angle B is congruent to angle E. And then we want to prove that if A is congruent to D and B is congruent to E, we want to prove that the third angle C, is congruent to angle F. So let's go through a quick little proof to do that. Now, I don't know why this line is right there in the middle of my page, but we're going to have to work around it. So let's talk about what we know. We know that the three angles of a triangle add up to 180. So we can say that angle A plus angle B plus angle C equals 180 degrees. And then we can say angle D plus angle E plus angle F. And I'm making a little mistake. We should put the measurement of all these, the measurement of these. Measurement, measurement, measurement equals 180. Okay, now I'm going to use the substitution. We know that by definition of a triangle. Okay, so now let's set these two equal to each other. The measurement of angle A plus B plus C is equal to D plus E plus F. That's all by substitution property. Now let's use our givens. We can say the measurement of angle D is equal to the measurement of angle A. We know that by, oh wait, I should write the givens first. Let's say angle A is congruent to angle D, angle B is congruent to angle F, so therefore those are givens. So the measurement of angle A is equal to the measurement of angle D and the measurement of angle B is equal to the measurement of angle F. Those are definition of congruent angles. I'm not doing this in a very nice, neat format as a two-column proof, but you're getting the information. Okay, so now we can use substitution. If A is equal to D and B is equal to F, I am going to take that information, and I said F, it should be E. Lord have mercy. What's my problem? B is equal to E. Okay? So, let's take those things and substitute them. So I'm going to leave the left side just as it is. And I'm going to stop using the measurement things, but know that it needs to be in there. A plus B plus C needs to equal the measurement of angle, and I'm going to substitute A right here, A plus E. I'm going to substitute a B right there, and then we'll leave the F. Now, if I subtract A from both sides, and I subtract B from both sides using the subtraction property of equality, we get that angle C is equal to F. So assuming we had all our little measurement things in there, the measurement of angles, we can say the measurement of angle C is equal to the measurement of angle F, and therefore we can say angle C is congruent to angle F. Definition of congruent angles. Now, I did the full proof for all of this. Okay, you see how we proved it. Now, what I want to show you then is how we would do it sort of in the shortcut version. If you're working on a proof going forward, and you're given that two angles of a triangle are congruent to two angles in another triangle, then we can say the third angles are congruent. So that's how we would say it in the future. If I just did a proof, if on this one we were trying to prove C is congruent to angle F, and if I was given these first two, like we were here, in your proof, you would do your two givens, angle A congruent to angle D, angle B congruent to angle F, given, given, and then you can jump right to angle C is congruent to angle F, and what's our reason? If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So I went through a long proof to show you that we can say that when we're doing a proof. If you've given that there's two angles of one triangle are congruent to two angles of another, we know that the third angles are going to be congruent. Okay, good? Let's move on to the next part. Okay, so on your papers, these numbers are typed in. I don't know why they didn't show up on mine. But it says solve for x and find the measurements of each angle. So we are given that these two angles are congruent and these two angles are congruent. So we know that our third angle is congruent. So we can say that angle C is congruent to angle F. And so we can set up our problem that 4x squared is equal to 3x squared plus 25. So let's solve. We're going to subtract 3x squared from both sides. So we get x squared equals 25. Now what do we do from here to solve for x? We're going to take the square root on both sides. And so x is going to equal plus or minus 5. Because negative 5 squared gives me 25 and positive 5 squared gives me 25. So we could put either, remember we're solving for f, not x, not for the actual angle. So you could put negative 5 in there, and so if you had 4 times negative 5 squared, you would have 4 times 25, which would be 100. And if we put negative 5 in this one, we would have 3 times negative 5 squared, which would be 3 times 25, which is 75, plus 25 is 100. So you can see they come out the same. Would be the same with positive 5. Okay, let's try number 11. Solve for y and find the measure of each angle. Now, on a question like this, sometimes it might be easier to take your triangles and make them look the same. So I'm going to draw around this one. I have this triangle right here. I'm going to take the other triangle and flip it around so it matches the one that I have. So this is going to be I right here, and this is J right there, and this is G over here. You see that? And then 6y squared minus 40. So these two angles are the same. These two angles are the same. And then this angle is the same as this one. So we can say that angle K is congruent to angle J. And let's go ahead and set up the problem. Why don't you try it without my help and see how you do. Okay, so I set up my problem. 4y squared equals 6y squared minus 40. I subtracted 4y so that this would be a positive number. And then I added 40. So we ended up with 40 equals 2y squared. Then I divided each side by 2. So we got 20 equals y squared. And then took the square root. So you get plus or minus the square root of 20. And then I went ahead and simplified that as the square root of 4 times the square root of 5, which is 2 radical 5. Square root of 20 simplified square root of 2 square root of 5. So plus or minus 2 times the square root of 5. A little bit tricky on that one, but that's how it works. Okay, so again, some of the typing on my copy didn't show up, but on your paper you have the BA is parallel to DE. And that the measure of x degrees is BCD. So we're trying to find this angle right here. So in order to do that, I'm going to say we're going to use an auxiliary line. And I'm going to draw a line that's parallel to both of these. And when I do that, now I have a transversal. And I know this angle here is going to be 62. And then I have a transversal this way between the two parallel lines, so this one's 55. 62 plus 55 equals 117 degrees, and that's the measure of that angle right there. I used an auxiliary line to help me. Now for these constructions, what you're going to do is take these shapes and then try and construct on the back the figures that they gave you, A, B, C, and D. I'm not going to go through that with you. You can look at mathopenref.com to remind yourself how to copy an angle, how to copy a line segment, and see what you can do with those. If you could do maybe, if you could do A, B, and C, that would be awesome, and we'll take a look. If you're having trouble with it, we'll talk about it in class. Okay, so there's your lesson, and we'll see you soon. Bye.